Welcome to sixth lecture from chapter number 9. We will continue studying pseudo and MOS logic, and here is a small recap. A pseudo and MOS circuit can be implemented by implementing an nMOS array. This is the same nMOS array that we have in a regular CMOS circuit, whereas PMOS array is replaced with a single PMOS transistor that is always on. The gate of the transistor is connected to ground. Right. Today we will implement different Boolean expressions related to different circuits, and will implement their equivalent pseudo and MOS implementation. So let's first implement this Boolean expression a dot b, a and b or c, and the whole complemented. We have studied in our earlier lectures that the precedence of AND operation is higher than the precedence of OR operation. So therefore, if we don't have parentheses and have these two operations, the precedence of AND operation is more, it's larger than the precedence of OR operation. So we will ourselves put brackets here. And we have also studied that to implement nMOS array, we have to implement the complement of this. For to implement PMOS array in the regular CMOS circuit, we have to apply De Morgan's law. Since this case of pseudo and MOS, we don't have to implement PMOS array, therefore we don't need to apply De Morgan's law. We'll just implement the complement of this. So if we complement this becomes without complement this small expression. So we will implement it in such a way that PMOS array, it is always on, and nMOS array implements A and B or C. So this precedence is more compared to this. So therefore we'll implement A dot B because having a higher priority, A dot B, and then this or C. This is the output F. So this is how we'll implement this circuit, whereas PMOS array will always be the same, composed of a single PMOS transistor, and that is always on. Right, let's move on to the part B. Let's move on to the part B, where we have to implement an expression H that is equal to A plus B plus C dot X plus Y dot C. Right, this means the precedence of this or of these two OR operations is higher than this AND, because we already have brackets here. So we have this these two operations and OR operations having higher precedence than this AND, and then this OR and this OR and this AND. So there are no brackets here, therefore we'll put these brackets ourselves, knowing that the precedence of AND operation is higher than the precedence of OR operation. The precedence of AND operation is higher than the precedence of OR operation. And then we will implement its complement to implement, and then we'll use its complement to implement the nMOS array. So now we are ready. Right. So we'll first implement this A or B or C, and then Y Z, and then we have this dot X. And then we have this dot X. So we'll implement this X because it is in series with it, and then plus Y and C. This is our output H. Right. So first these three in parallel, then this in series because it's AND operation, and then this has a higher precedence, so I'll implement this first and then we'll add these two arrays. Right. Let's move on to the third part of the example. Where expression f is given to be a plus c dot x plus y dot z and this whole. So it's pretty straightforward. We'll first implement this AND operation, then this OR, because these are in brackets, they're higher precedence, and then dot C means AND C and then OR A. So we have to implement its complement. We have to use its complement to implement nMOS array. So this is the PMOS array. To implement nMOS array, we first need a y dot z. Y dot z is implemented like this, and then we have to add an x to it. This is adding x, an OR operation, and then dot c. Dot c means this, and it with c, and then we have this OR A. C and then we have this OR A. This whole. So first we have implemented this AND operation, then this OR, then this AND, and then this OR. So it's pretty straightforward. Let's go ahead to solve the last part of this example, part D. G is equal to x dot y plus z dot w without any parenthesis. So we know the precedence of AND is more than the precedence of OR, and we have to use the complement of this expression to implement nMOS array. So the PMOS array is as such composed of a single PMOS transistor, always on, and then we have to implement x dot y, z dot w, and then we have to add these two, means apply OR operation. So x dot y, z dot w having higher precedence, and then we have to OR these two arrays to implement this nMOS array, the full nMOS array. Right, we'll keep on studying more from chapter 9 in our upcoming lectures. Thank you.